Hello, I want to continue with our lessons on partial fractions. We've already dealt with linear factors in partial fractions 1, then we dealt also with quadratic factors in partial fractions 2. Today, we are moving on to partial fraction 3, and that is on repeated factors. Repeated factors. So this is what this term, that's the repeated factors. The power can be 2, 3, 4, 5, and so on. And so when we have a rational function of this nature, then we can express it in partial fractions this way. So a on 2x minus 3 from here, and because this is repeated to be b on x plus 5, and then c on x plus 5 squared. In case this is 3, then we can extend it to plus d on x plus 5, or is the power 3, and so on. So look at how we capture it when it's repeated, when the factors are repeated in the rectangular green box. So look at it carefully and register it. Align yourself with the process. Splendid. So let's move on to question 1. Express 3 on x into 3x minus 1 all squared in partial fractions. And so straight away, we have our rational function on the left-hand side. That will be equivalent to a on x. And then because this is repeated, b on 3x minus 1, then c on 3x minus 1 all squared. Then we multiply the left-hand side and the right-hand side, every term by the denominator. And so when we do that, we clear off the fractions. And so this will multiply by itself. So we get 3. We multiply the whole of this a on x by this. So x will clear this, and then we'll be left with this part. So we get a times that. Then 3x minus 1 will divide one of this. So we shall get b times x, 3x minus 1. Now, the whole of this, because it's squared, will clear this. So we shall get x. So c times x. So we've been able to simplify it to this point. Now, I want to compute the values of a, b, and c. And when we look through, we have to find a way of clearing this and that so that we can get our c. Now, for us to do that, then we substitute 1/3 for x here. So that 3 times 1/3 will be 1, 1 minus 1 will be 0, and that the same scenario will be here. So this and that will be cleared. So we shall get 3 equals 1/3 c. Then multiply this side by 3, that side by 3, so we shall get c equals 9. So c has been calculated. Now, we already have this. Now, I want to expand it. For us to expand, we shall get this to give us 9x squared minus 6x plus 1 from binomial expansion. And this one is also 3x minus 1. So we expand this. So we shall get 3bx squared and then bx plus cx. Now let's group the like terms. So we shall get the whole of this x squared, the whole of that x, and then plus a. Now I want to compare coefficients of x squared. When we do that, it will give us 9a plus 3b. So over here, the coefficient of x squared is 0, so that will be equal to 0. Now 9 and 3 are common, so you can divide through by 3, so you get 3a equals 3a plus b equal to 0. Let's call that equation 1. Now, for my expansion, we've seen that a is a constant, and that will be equal to 3. So straight away, we say a is equal to 3, and that is a constant. Now, from 1, substituting a equals 3 gives us 3 times 3, because we substitute this 3 for a. So we shall get 3 times 3 plus b. And that means that our b is negative 9. So we've been able to obtain all the values, our a, our b, and our c. And so we go to the original expression, and we'll do the substitution. So in place of a, we put 3. In place of b, we put negative 9. In place of c, we put our value 9. And that finishes everything. Great. That finishes everything. So let us go back to the question. Let's go back to the question and see. So that's how we express it. And we've gone through this question. So look at it carefully. recall the way I explained it, and register the process on your mind. It needs patience. It needs consistency. It needs persistency. Thank you so very much. Let's look at another question. Express x on x minus 1 into brackets x minus 2 all squared in partial fractions. And so we write it this way. Our a on x minus 1 goes a linear factor. Then this one, this factor is repeated. So b on x minus 2, c on x minus 2 all squared. Then we multiply every term, both on the left-hand side and the right-hand side, every term by this expression. When we do that, we shall get x equals the whole of this. We now have to compute our a, b, and c. So for us to get our a, we need to clear our b and c. So we shall substitute 1 for x, so that 1 minus 1 will be 0. This will be cleared. 1 minus 1 will be 0. That will be cleared. Then the 1 here will be 1 minus 2 will be minus 1 squared, and that will give us 1. And so our a will be equal to 1. Fantastic. Now, we want to substitute 2 for x. Now, when we do that, it means that this will also go to 0, that will go to 0, and then we shall get our c, right? So that is why we got 2 being equal to c, so our c is equal to 2. Because when 2 is here, this goes to 0. When 2 is there, that goes to 0. And then when 2 is here, we get 2 minus 1, 2. So we get c equals this 2, because 2 also be there. So that's why we have our c to be equal to 2. Great. Now let's compare coefficients. So comparing coefficients of s squared, we've seen that a plus b, when we come here and compare coefficients, we have the whole of this. So a, the squared here, so ax. Then x times x, so we get that. So a, because of the square, we shall get ax squared. Then here we shall get bx squared. And then there's no coefficient of s squared here. So a plus b will be equal to 0. But we know that our a is 1. From here, our a is 1. So 1 plus b equals 0. It means b is negative 1. So we've gotten all the values. We've gotten our a being 1, b negative 1, and c 2. So let's go back to the original expression. Then we put in our values, and that does it. So we have our a, we have our b, we have our c. Right, so let's go to the beginning of this question and then try and recall how I did the explanation, how we capture this in this form when the factors are repeated, how we multiply both sides by this expression, clearing of the fractions, and simplifying it this way. Then starting by substituting 1 for x, giving us a equals 1. Substituting 2 for s, giving us c equals 2. Comparing coefficients of s squared, where we got a plus b equals 0, and knowing our a being 1, we got our b to be negative 1. Then from there, we now substituted the values to get what we were looking for. Great. That does it for today's lesson. We've gone through repeated factors under partial fractions. Take note of all the 3 aspects: the linear factors, quadratic factors, and then repeated factors. Try your hands on a lot of them. There'll be other examples that you may need also to check whether the power of the numerator is less than that of the denominator. If it's greater, then you need to find a way of simplifying it such that the power of your x will be less than the power below. So check that. There are lots of examples that you can explore, and then that will help you to get grounded, to get hands-on almost all the problems and the partial fractions. Keep on trying, keep on practicing, and that is the key to becoming a great mathematician or someone who loves numbers, patterns, shapes, and many more. Thank you for your time and have a blessed day. Bye.